in a slightly more complicated form of the fundamental theorem problems, we're asked to find the derivative of an integral from a constant to not just x, but some function of x, integral of f of t dt. Right, so now here we have a function here, and that's going to make things a little more complicated. Now, let's, as we did before, let's assume that f of t has an antiderivative, and let's see if we can derive what's going to happen. So if this had an antiderivative, then we could find it. And evaluate from a to g of x. So we would plug in g of x, and we would plug in a. And now we can take the derivative. Now here we have a composition of functions, which means we're going to need chain rule. So we're going to take the derivative of the outside function. Derivative of big F, remember, is little f. By definition, it was the antiderivative. Derivative of the outside function, evaluated at the inside function. Chain rule says times the derivative of the inside function. And again, the derivative of big F of a, this is a constant, so it will be 0. And so we end up with the original function evaluated at g of x, evaluated at this function, with a chain rule times the derivative of that inside function. Okay? So, let's try that in an example. So let's say I needed to find the derivative of the integral from 5 to x cubed of tangent squared t dt. The fundamental theorem, the version that we just derived, said the derivative will undo the integral, getting me back to the original function of tangent squared, evaluated not at x, but at this function, so at x cubed, times the derivative of this function here, right? So times a chain rule, so times 3x squared. And there's the derivative of the integral.